If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
So what I'll do today is I'll try to cover up the concepts of distribution, the most famous distributions in our world. Then I'll try to give you a bit of highlights about sampling. And because I think there is a lot of statistics and probability that I have been teaching, so I just wanted to introduce to you a new concept, the concept which is very famous in the machine learning world. So it is the building block of machine learning as such, we say, so that you keep up the interest. Correct. So what I'll do is eventually I'll keep teaching statistics, and one line would teach machine learning, and then I link this both whenever I show you the results of machine learning algorithms. Correct. Okay. Biofarm, I think you attend all the classes, but then I find no participation from you, which would be a bit difficult for me to assess you or to know where you lack or what you want to know unless you interact. Okay. No issues. Aarti, let's go ahead then. What I'll do is I'll show you the slides. So yeah, what are we going to discuss today is Poisson's distribution. We'll look at a bit of sampling, and we'll look at the idea of regression. Okay. So as discussed, we were discussing something about binomial distribution. What happens with binomial distribution is you have a certain number of chances that you use upon the experiment, and then you have only two outcomes of the experiment, success and a failure. And we use those two values and the number of times the experiment is being done to find out the probabilities of a certain new iteration that might be used by us. Correct. So basically, there is a way where we find the probability of a new, new iteration or a new row in binomial distribution. It is called binomial because there are two things: a win and a lose. Right. Now, as we are discussing of discrete kind of distributions, there is one more famous discrete distribution, that is the Poisson's distribution, just like the binomial distribution. Okay. So Poisson distribution is something that focuses on the number of discrete occurrences over a particular interval. Okay. Don't worry if these words are a bit confusing. It will be cleared after we discuss some of the examples ahead. Okay. Let us discuss that through some examples. Like when we do a binomial kind of exercise that was taught in the previous class, binomial experiment might be used to determine how many US made cars are in random sample of 20 cars. Correct? A Poisson experiment might focus on number of cars randomly arriving at an automobile repair facility during a 10-minute interval. Do you see the difference? Usually Poisson distribution is a way in which you find out anomalies. And when and how do you do that? You do it over a particular interval of time. Here 10 minutes is an interval. Okay. That is what I was saying. It focuses on the number of discrete occurrences over some interval or continuum. But in binomial distribution, we were not focused on interval kind of thing. We were focusing on the amount of experiments that we do and the probability of success and failure only. Okay, let me give you one more example where Poisson distribution can be used. This is a very common use case where we find the number of random customer arrivals per 5-minute interval at a small boutique on weekday mornings. Okay, this is one kind of use case which will give you a sense what Poisson distribution is used for. Usually in our day-to-day life, companies, bigger companies who have very faster turnout rate, like McDonald's or KFC, or these similar kind of fast food, high speed moving food products. So what they do, they usually try to measure in a particular interval how many people are about to drop into their stores. So what that helps them to do is that helps them to decide how many counters do we need to have in our shops, or how much people can we cater to. That is being solved using the Poisson distribution. Okay. The models used in queuing theory, exactly that I was discussing. The people who stand in queue and collect the items one after other, this is called queuing theory, usually assumes that Poisson distribution is the proper distribution to describe random arrival rates over a period. Focus on this word, over a period. How many people will randomly arrive over 1 hour or 5 minutes or 10 minutes? That is how a Poisson distribution separates itself from other distributions. Okay, there are only particular use cases where Poisson distribution can be used. Okay, now let's see what Poisson distribution characteristics are. Okay, it is a discrete distribution. As we already discussed, what is the difference between discrete and continuous? It is a discrete distribution is the first point. Okay, and it describes rare events. What does rare event mean? Basically the anomalies, something which is not usual, business unusual kind of situations. Okay, each occurrence is independent of the other occurrence. That is where we were looking into probability. These are independent events. Only then a Poisson distribution holds good. Okay, it describes the occurrence over a particular interval. As I said, you have to pay attention to these. Okay, the occurrence in each interval can range from 0 to infinity, right? And the expected number of occurrence must be constant throughout the experiment. It should not be that I think I'll confuse you. How to explain this point? The expected number of occurrence must hold constant throughout the experiment, which means suppose we are saying that on an average in a McDonald's store or a Starbucks store, around 5 people come into the store in 30 minutes. Correct? Now for my experiment, I will always consider that the number is 5. It should not happen that after 30 minutes I'll say the average is 6 and then calculate. that value should not change. Did I confuse you? Can anybody ask me some doubts?
Yeah, you said the average will not be 6, but
Right.
it should not be 6 because yeah, you are saying 5 people are coming over a 30 minutes interval.
Yeah.
So we can say like every 6 minutes.
6
But
minutes is a different thing. So here, what is most important in Poisson distribution is the time of interval that you are considering for your exercise.
correct.
Okay. So now if somebody has asked, what is the probability that 12 people will come in 30 minutes? For that, your assumption that usually 5 people come should be constant. Your assumption of 5 people should not change. Just have it in mind. Okay.
Okay.
We will go to a example and then we will discuss this and understand it more better.
Okay.
Okay. So Arti, you remember the binomial formula? The formula that we were using for the probability of a binomial distribution was combination of nr p to the power r q to the power n minus r. Do you remember something like that? Hello, am I audible?
That was n factorial
Yeah.
divided by x factorial
Yeah.
and then multiplied by n minus x factorial
Correct. Which
times
can
p
also
power.
be
Yeah.
called as combination NR, CNR.
CNR. What was?
You remember permutations and combinations?
Yes.
The combination formula. You remember the combination formula?
Please, I don't remember the combination formula. That
Show it here. So combination of n comma r is usually given by n factorial divided by r factorial into n minus r. Is the formula same?
right. Yeah, this is the formula, but there was few other.
Yeah. What are the other things?
That was the p keep p. There is the power of x of the p,
Yeah.
and then multiply by q to the power n minus x.
Right. You remember what are P and what are Q?
P was the probability of getting the success.
Correct. And Q is the probability of getting failure.
Error. Yeah, failure.
Okay. So now if those things are remembered, similarly,
What is
for the Poisson's distribution, probability of finding X is lambda to the power X e to the power minus lambda by X factorial. Now only thing that you don't know here is lambda, right?
Yes.
X is something that you will find out. E is our exponential E, log E wala E.
Okay.
2.71, that is a constant value. Okay. Now you have to know what is lambda. We call it as long run average. Okay. But then let's look at a form question and then understand how this formula works. Suppose a bank customer arrives randomly on weekday afternoon at an average of 3.2 customers every 4 minutes. Correct? Now this 3.2 customers every 4 minutes is our assumption. This 3.2 customers should not change. If it changes in our experiment that you are going to do to solve this question, if this 3.2 is constantly changing, then Poisson distribution does not hold good.
So that means this value should be like fixed. The average you were saying, as we have to keep it whole. Yeah, it says.
The expected number of occurrence must hold constant throughout the experiment.
Okay.
So this is the occurrence. 3.2 customers are occurring in 4 minutes. This should be constant. Okay. Now, what is the probability of exactly 5 customers arriving in a 4-minute interval on a weekday afternoon? So this is the question. Did you understand the question?
Yeah, I got that. So, but
So the question is saying, on an average, usually we find out that 3.2 customers hop into the store in a 4-minute window. Now tell me, what is the probability of 5 people coming in? Okay. This is basically the question. Now we have to look at how to solve this. Now, when we say lambda is something which call as long run average. Remember this word, average, which is running since long. Remember it like that. In this question, suppose bank customers arrive randomly on weekday afternoon at an average of 3.2 customers, correct? This value is lambda. Okay. And we have to find the probability of exactly 5 customers. Now this 5 is X. They want to find out the probability of 5 customers. X is 5. Okay. Now, how would you find that? So, Aarti, if you have worked out or if you remember how we did for the binomial distribution, you can just quote the formula.
let me try. Yeah.
Use an Excel kind of setup. It will be easy.
Yeah, I'm going to do that. Yeah.
Use the power function.
Yes, I'm doing that. Point 1139.
Yeah. 0.11 is what I remember, but yeah, it is correct almost.
Okay.
So Aarti, you got the concept. I mean,
Yes.
what kind of problems we solve using Poisson distribution?
Yeah, I got that. Yeah, we need to have some interval like that,
Yeah.
lambda or some kind of things to find out that other things. Yeah.
You need to have an average. You need to have an interval,
Yes.
basically, because in this function only 2 things are unknown. That is X and lambda.
Correct.
So lambda is a long run average. Remember this term. And X is the unknown. Correct.
Correct. Correct.
You remember what are the use cases we used? So like, what is binomial distribution used to solve?
Binomial is just for the 2 outcomes,
Like,
win or lose or anything like.
correct. So can you give me an example, like where can we use a binomial?
Yeah, like it's in the bank, we can say like the customer who will stay in the bank or he will leave the bank. I
Oh,
think.
yeah. You're correct. But
Yeah.
why did you give this particular example?
Because I just look at the bank customer. Okay, let me see the another one then. Think.
It's a simple case of head and tail.
Yeah. Right.
right? Or the simple case of India winning or losing.
Yeah. Anything, yeah, like that. Yeah, just there are two answers, yes or no, something like that.
Correct. And the reason that we have a yes or no kind of setup in binomial, or,
Binomial, yes.
or in case of Poisson, we have a lambda and x kind of a situation. These give us result in discrete mode. Okay,
Correct.
the functions are usually discrete, so we call it a discrete distribution.
Got that.
Hello. This E value for E always be like a 2.718282.
Yeah,
Okay. And what about this value of the A? Oh, this is a lambda or something. Power by.
it is lambda.
Oh, okay.
You are Rabindra, right?
Yes.
Okay. Okay. So Aarti, can you just read question number 2 and tell if you understood the question?
Let me see. Bank customer arrive randomly on weekday afternoons at an average of 3.2 customers every 4 minutes. What is the probability of having more than 7 customers in a 4-minute interval on a weekday afternoon?
Correct.
So in this case, the X would be 7.
Would it be 7?
Yeah.
Are the question number 1 and question number 2 same?
No,
What is the difference?
because that X, it says here the exactly 5 customer, but here they are saying more than 7.
So it can be 7, 8, 9, anything, right?
Anything after 7, yes.
So you have to give all the probabilities from 7 onwards till infinity,
Okay.
and then you have to add those probabilities.
Okay, so then how we are going to solve that thing? How we are putting these value in this formula?
Okay. So why don't you do one thing? Why don't you calculate for x equal to 8, 9, 10, 11, 12, and 13.
Okay, so then we need to calculate separately, right? For that 8, 9, 10 separately. Each.
Yeah, calculate from 8 till 13.
13.
1, 3, yes.
Okay.
Put the values of x, get the probabilities, and add them. Or see what is the probability. Tell me the probability of each of the values from 8 till 13.
Okay, got it.
So why only till to 13?
Why don't you do and you'll understand. Are you guys stuck? Is it going good?
No. Actually, I am calculating, so yeah. I think it should. If we keep the value x is equal to 8, then the probability is 0.00111.
Correct.
And I think same way we can calculate for, I have to.
Where am I doing the mistake?
I think you need to put the power that 2.7 minus 3.2.
You got this value?
For the first one, right?
Yeah.
No. Which one? Like you are saying
X equal to 8.
x is equal to 8.001111. How come? There are 2 after decimal.
Or how different? What have you done different than this?
Yeah, that's what I'm thinking now. I've done the same way. Let me see. And what was the E value? 2.7. 2.71828. Okay. Yeah, I don't know. Maybe I made some mistake because I was doing separately. So yeah, but I got the correct now. This 8.
Okay, so
Yeah, I got that. This one, and then what we need to do, the add all together.
just have a look at this. That
Okay.
when you had to do only 5, you found out this result. But if
Correct.
someone asks you if it has to be more than 7, then where will you stop? Right? That was the
Yeah,
question
that's
exactly that Ravindra asked. So why till 13? Why not till 100 or 200? When you see these values, you see till 12. There is some significant probabilities. After 11, it decreases to a lot, and 13 becomes negligible. So this is the sum from 8 till 12. The value is this much. Now see, if I add 13, it is almost like adding 0. If I add 14, it is almost like adding 0. Correct? Now that is where you know that you have to stop, because the probability of 13 people coming to that store in those 4 minutes is almost 0, which means most of the people won't come.
okay. So that means we have to check where we get the probabilities close to 0. Then we should stop there.
Exactly.
Okay. Okay. The sum of that probability. Okay. Got that.
Got it. So how will a business use this value? They will know that maximum on a peak time, probably only 12 people will come in 4 minutes. So I have to make arrangements that 12 people can have their food or have their uh, banking queries resolved. I have to set my bank in such a way. I need to have so many kiosks so that 12 people needs to be served at a time. This is how the counters or the various businesses use Poisson distribution to solve their problems. Okay.
Okay.
I hope this concept is clear.
Yeah.
Okay. So as we discussed in binomial distribution, we were saying that there is something called as the mean of distribution. Do you remember what is the mean of a binomial distribution?
Mean of.
Why don't you just check the previous material? Did we discuss something about mean of a distribution or expectation or something?
Mean or expected value.
Yeah.
Yeah, I'm just checking on that material. The sum of an outcome then multiply by the probability of that outcome.
Okay. Is it NP?
No,
N into P or something?
that is x multiply. Yeah, that is like mu is equal to E multiplied by X.
For are you reading for only binomial or you're reading in general?
Just it's for the discrete one.
Is there something for binomial? Please go into
Binomial, let me check. In the binomial, we haven't done any mean, but in the distribution,
Okay. So was the material really uploaded a bit late or something? You guys.
yeah, he uploaded late. Actually, I know that.
Okay.
Yeah, they don't do it on the time actually. Yeah, because the classes are on Saturdays and Sundays. What they do, I requested several times. Then they uploaded like on Thursdays.
Okay. It will be done on.
Yeah, I want to be because yeah, whenever we get time, at least we can finish and we can read through that material.
Okay. So that will be given to you by Sunday night.
Yeah.
Okay. Okay. Anyways. So basically, as we discussed that in previous classes, for any population that we gather, we always try to find out the mean or a median value. What it will help us? It will help us tell what this distribution is, what lies in it. Okay. So in this Poisson distribution, the mean is the lambda. You don't have a formula or anything because logically, that is the average that we have already taken into consideration. We find out probabilities basing on that average. Okay.
Okay.
Now, as we were discussing about as we were discussing about discrete distributions, we also have something about known as continuous distribution. Do you remember the difference between discrete and continuous distribution, or discrete or continuous data as such?
Yeah, the discrete is that integers and the continuous with the decimal points like height, weight, and all these things.
Correct. So if you plot discrete values on a graph, you will usually get a histogram or a bar graph kind of situation, right? But when
Right.
you plot these continuous variables, you will always have a continuous graph. There won't be breaks between 2 points. Okay. And the most famous one is called normal curve. Did we discuss about normal curve earlier?
No,
We have not discussed about normal curve. Did,
no.
did we discuss about z value, z value?
Yeah, yeah, that, yeah.
Did we discuss about mean, median, mode being same of a curve?
Yes, yes, that I know. Yep, yeah. Then it means the normal distribution, yeah, if it has the same value.
Yeah. Now you remember what is normal curve?
Also, the normal curve mean the normal distribution?
Yeah.
Okay, okay.
Right.
Yeah,
Distribution is basically a statistically used word, but which basically means a curve.
okay.
Okay. So as we have discussed how a normal curve's properties are, I just wanted to say that when this was discovered by the mathematician who made it, he recognized that the errors of repeated measurement of objects are often normally distributed. So what he basically, so if you remember, I was saying something about the central tendency.
Yes, I remember.
So if you try to capture one kind of thing from a sample or a population many times, the data tends to circulate or revolve around a central point, making it look like a bell curve, a bell-shaped curve, which is given the name of normal curve. Okay. Now, what is the difference mathematically for a continuous distribution and discrete distribution? In a discrete distributions, we have to find out the probability of discrete values. Like in the Poisson distribution we were discussing, what is the probability of 5 people coming into it or 7 people coming into it? But in continuous distribution, what happens is uh, you can't have a point value for that particular x. What would be the question look like? The question would be what would be above x, or what would be below x, or what would be in the range of a to b. If you remember, I was discussing about a curve, and then I gave you the example of a bulb failing,
Yes.
and then I asked what is the probability of, or how do you say that 16% of the bulbs would lie in? What is the probability of them? You remember some questions that we did like
I
that?
remember. Yeah, yeah, yeah. Because look, like, yeah, calculating with the standard deviation from the mean and all these things. Yeah.
Correct. So in that, the question should be like that. So how much percent would lie in this area, or what do you think? What would be the probability of uh, bulbs not being failed greater than 7? So basically, it will be area kind of questions, not discrete kind of questions.
So there will not be like fixed number. We can say like it's like infinite number. Any number could be there.
Exactly.
Yeah.
It
Okay.
will ask you about an area. Okay.
Yeah.
And so Aarti, you have exposure. You had exposure to integration and all.
No.
I mean, do you know the concept? What integration does?
No.
Okay. How do I say? So there are these two famous concepts of integration and differentiation in mathematics. So what happens is, think of a curve, a sine curve. You know a sine curve.
You mean the sine and cos? You mean then?
Yeah.
Okay.
Just a minute. This is a sine wave, right?
Yes.
So think of this as a curve. When you do a differentiation, what you do is from this whole curve, you find out one point. Okay. And when you do integration from this point, you make this graph.
Okay.
Integrate things and differentiate things. Okay.
Okay.
Now, if you have this curve and you have to give like sin x is the function of this curve, right? If you give the value of x into a function called sin, it will return you graphs like this. Now, if I have to have a normal curve, I need to have a function exactly like sine. So what would be that function? This is the function value. For every x with a particular standard deviation and a mean, if you keep plotting these, you will have a normal curve. Was it confusing?
Yeah, a little bit. Because yeah, I haven't read about this integration and also.
Let me think of an alternate way where you
Yeah,
can.
just an example, maybe so then I can get some idea.
Mm,
That's the only thing I can say.
no, actually, this is not about real life examples because examples I have already given to you when I asked you to solve those bulb problems.
Mm-hmm.
It was about those examples.
Oh, okay. So I think that should be okay. Maybe because theoretically I will see.
In which slide we did that? In slide number 3?
The bulb thing, I think, yeah, in two. In two. Oh, well,
Yeah,
yeah, in two.
this one, right?
Yeah,
This is a normal curve. So these are x values here. This is x and this is y. Think of
yeah,
a coordinate geometry notebook that you had in childhood.
yeah. I remember, yeah. X and
You
Y
had
coordinates, yeah.
x and y coordinates.
Yeah,
And if you keep giving the values of different x's,
on the different Y, yeah.
and some value would come in y-axis, right?
Yes.
Now, how much value would come? How would you find that out? You have to put it in a formula so that it gives you this result, right?
Correct.
This much, this much, this much, this much, this much. That formula is this function.
Okay.
Like for sine x,
If we
here,
put that value, yeah,
if you give
got that.
360 degree, you are getting this value. You are giving 270, you are getting this value. Sine of x, correct?
Yeah, we would know Y value, yeah.
Similarly, for a Gaussian distribution or a normal curve, a curve that I was showing you here, this is a normal curve. For this curve to happen, this is the function that we'll use.
Okay.
Now, what will happen every time you change the value of mean and standard deviation, a new normal distribution will come. Isn't it right or wrong?
Every unique.
Where was it? Yeah. So for a different mean and median, the
Oh, yeah,
curves would change, right?
correct.
So what should be done so that there will be a standard normal curve that will be established and we can find out results? Because it would always keep changing and we will not have any reference point to refer. correct? So for that, what we did a standardization. We call it standard normal distribution, from which the concept of Z came, Z value,
Z score, you mean, right?
Z score.
So standardization means we are doing the value on the same level, like on the same platform. Like there are some values sometimes like higher value and some negative value. So we will standardization means like we are keeping on the same scale.
Yeah,
Okay.
we can say that um, within one standard deviation, how much data would be there.
Right.
So to bring out that concept, we had to do a Z scoring of it.
Yes.
Okay. I think I have discussed this earlier also. If you revise the slide number 2 and 1 once again, then you will connect to this.
Yeah, I will do that.
Okay. So that is why, now you get why I was giving so much emphasis on the basics.
Yeah.
This is what
Yeah.
happens.
Yeah.
Eventually, when you go ahead with machine learning, things get more and more complicated.
Correct.
So eventually, if you start learning slowly and easy with your all assignments, then your understanding becomes a bit faster.
Yeah, that's correct.
Okay. Let's go to the second concept today, which we call as sampling. If you remember from my first class, I was discussing about something called as statistic, population, sample, measures.
Yes.
Uh, there I was telling an example that usually when we go to the blood camps, people collect a sample of blood, because
Yes.
of course they cannot collect all of your blood, you'll die, right? So
Right.
how do we collect a good sample? What is the process, or what are the methods that we can use to collect a sample from a set of population, and why do we do it? Is there a need to do it or not? Okay.
Yeah, because to make it bias like sample, because if we just choose a sample from one area, then it won't give the right answer, right? From
To
the
make it
population.
unbiased.
Unbiased, sorry, yeah. That's a thing. If we just choose a sample from like just one area, one class, anything like that, to get the
Exactly.
random sample, I can say that.
So we want our results to be as random as possible.
Yes.
Exactly like real life events. Our real life
Yes.
events are very random in nature.
Correct.
Okay. So I'm just citing out why do we do it.
Yeah.
Taking a sample instead of conducting a census offers several advantages. The sample can save you money, right?
True.
You have to collect only some amount of substances. The sample can save time. For given resource, the sample can broaden the scope of study. You understand? Though we have a less sample, but our accuracy or the statistic that we develop might be very closer to the
Parameter. Yeah.
parameter,
Yeah.
correct? And
Yes.
because the research process is sometimes destructive, the sample can save product.
Yep.
Okay. If accessing the population is impossible, the sample is the only option. Just like our example of who would win the election. We can't go to the all of Indian people and keep asking everybody who do you think will win the election, right? So we have to collect a sample in that case. Now, what are the various methods of doing it? Okay. So though these methods look very simple now, when we go ahead and implement the algorithms, you will find that these simple concepts evolve into making a bigger one. Okay. So just understand this intuitively. Okay, so the various sampling techniques, the first one is simple random sampling. What happens here is our systems or our any of our coding platforms or computing or calculating platforms like Excel or Python or C++, everybody have their own inbuilt random function. So what it does is it randomly allocates memory to the it randomly allocates a number to the memory that is available in that system. Basically the numbers in the random function of Excel. You see, these values are changing and they are randomly being allocated. There is a reason to this. I mean, it happens without any logic as such. It just happens based on the first available slot in our computer system. What we usually do, we try to link these random functions to our real life problems. That is when we call it as simple random sampling. Okay. Now the second type of thing is stratified random sampling. So what we do is, here we choose the data from various stratas of data. Our example of who would win the election, if you remember, what we were saying is we can't only ask to a state of Kerala and then give our conclusion who would win the election. That would be wrong. So we have to collect people from various stratas, like from Kerala, like Tamil Nadu, like Maharashtra, Madhya Pradesh. And from each of these states, we also have to collect various castes, various religion, which are each of them is one particular strata. From them, we have to collect certain people and then ask them their results. For example, if I have to choose what is the average age of a particular country, okay, so I have to choose what is the what could be the question? Yeah. So suppose if I have to choose that, find out the answer to this question, that what would be the average age of any country like Japan or India or something. Then from every age group, I have to find out a certain number of people. Only then my study would be satisfied, right? Now to do that, I'll define various stratas. Like 20 to 30-year-old is one group, 30 to 40 is one group, 40 to 50 is one group. And from each of them, I'll try to find out a group of or a set of people. And then try to work my hypothesis or my examples on them. This way is called stratified random sampling. Then there is a third kind, which is called systematic sampling. So here what we'll do, a kth item is selected from a sample or a population of size n. So basically think of 100 people standing in a row. We say that we want to find the average age of these 100 people. Now we need to have a sample. So what we'll do, we'll choose all the people who are a multiple of 4. So 4th, 8th, 12th, 16th, 20th, all these guys will come. We'll find out their age and finalize our result. This kind of study is called systematic sampling. when you see this formula, K is equal to N by N. N is the population size, which is 100. N is the sample size, that is, we want 20 people or 30 people or 40 people. K is the size of the interval. If we want 20 people, then 100 divided by 20 equal to 5. So every fifth person would be selected. Is that understood? Do we have
Yes.
doubts? Okay. And then there is something called as cluster sampling. What happens here is this involves dividing the population into mutually exclusive sets and then try to sample from it. Okay. Now, Arthi, can you tell me what is the difference between stratified random sampling and cluster sampling? Did you get the?
Yeah, I'm just thinking how to. So in the stratified, since we make the groups like in the bins, like the ages, and then we choose the sample from there. But in the clustering, we make the group of each, like,
I didn't get that.
I'm a little confused now. I'm thinking how to explain it.
I'll tell you the difference.
Okay.
In both these cases, whether it is stratified random sampling or whether it is cluster sampling, we are taking different clusters first, right?
Yes.
Here also we are making clusters, here also we are making clusters. But where does the difference come in is in a stratified random sampling, we are choosing from a homogeneous set, which means this set of people are only from Kerala. This set of people are only from Tamil Nadu. This set of people are only from Manipur. The sets are homogeneous. The clusters that we make in stratified random sampling are homogeneous in nature. In cluster sampling, the clusters that we take are heterogeneous in nature. It is more random in nature.
Okay.
You are getting the idea?
Yeah. So it means like random means like they are not in the same nature kind of thing, right? Just we are making the groups.
Yeah.
And in the homogeneous, it means they should be same area or whatever, like they should be alike.
Yeah.
Okay.
That is what homogeneous means, right?
Okay. Yeah.
You might want to write this up because
Yeah.
I have not given it in the slides, but I'll ask the questions.
Yeah, I think that will be good. Yeah, if you like put it later, because then when we see the slide later, yeah, or maybe I will make my notes. That's the only thing. Yeah.
I mean, if I give everything on slides, it would be like you would be reading a book.
Right. Correct.
What is the point of attending the class?
No, that's good. No, maybe later on when you upload the slide.
Sure.
Yeah, that's the only. No, not in the class. Yeah. But that's okay. Yeah.
Okay. So if you got the basic logic, we'll move ahead.
Yep. Yeah, I got that.
So now we have discussed a lot about statistics. We will keep discussing. There is still a lot of things left, like 2-3 classes more. But then I think it is getting too technical and too boring for you guys. Okay, so I want to introduce you to something which I think in your research also you would have heard this, something called as a regression study. Did you ever come through this technique or heard of this earlier?
You mean the regression?
Yeah.
Yes, I heard that.
Okay. Let's go back to our previous classes. Let's revise some concepts to come to this. Okay.
Okay.
You remember I was discussing something about correlation.
Yes.
We had a correlation coefficient also.
Yes.
I think I have an assignment also given
Yes.
on correlation, right?
Yeah.
Now, what does that correlation mean?
So correlation means how, like, if we have two datas or two variables, so how they are related to each other, maybe in the positive way or in the negative way.
Correct.
That's the thing. We see the correlation, how they are related to each other.
Yeah. So, let's take an example of temperature and rainfall. I think that is what we were taking.
Yeah.
Correct. So, if we have the measurement of rainfall in centimeter and the temperature of a city, and we want to see what is the correlation. If the correlation comes good, so okay. So, what is the range of correlation?
I think you just wrote it -1 to 1.
Exactly. Right. So, suppose the correlation comes to be 0.8.
So it's positive.
Which is positive, which means
Yeah, it's going in along the way. Yeah, it's going in the positive. Like both are related. Like something happens, then it will increase, kind of thing. Yeah, same thing.
yeah, very correct.
Yeah.
So, but can you like, looking at that correlation value, can you say that rainfall is causing temperature? The temperature is being caused by the rainfall. Can you say that using the correlation number or not?
I think it won't be positive in the temperature and rainfall.
It would be negative. Okay, so
Yeah.
suppose it is negative. Okay, suppose it
Okay.
came as negative, and so what would be your conclusion out of it? What will you derive out of it? Can you say that the temperature is being caused by the rainfall, or rainfall is caused by the temperature?
We can say they are not related to each other, maybe.
But your coefficient has come to be,
It as negative, yeah.
which means they are related in some way, right?
Yes.
Okay. How will you prove that? I mean, by using just correlation, can you prove that rainfall is being caused by temperature or temperature caused by rainfall? It cannot be done.
I think we need to put in the formula to see that.
No, there is no formula as such. Okay, that is what I'm saying. That correlation is a different thing, but causation is a different thing.
Okay, I got that. What do you mean?
A rainfall might be caused a 5% due to the temperature, but then there are 95% things more. Temperature only has not caused rainfall, or there would be chances that it did not at all cause rainfall.
Yeah, could be.
There are other things like your trees being cut or your soil erosion or water.
Humidity, yeah, other factors, not
Other
just
factors.
yeah.
Right? It can be anything.
Yes.
So how do you prove that causation? Is there some study where somebody can statistically say that yes, this thing caused this. Okay. Now we have a lot of things in statistics, but then what we do is we club those things, make a model out of it, and then give the reason that X caused Y. Okay. And
Yeah.
that in
Hmm.
today's world is called as statistical learning, which is the basic building block of machine learning. Okay. Now, as I said, the correlation coefficient ranges from -1 to 1. Causation is not implied by correlation. Causation is quite difficult to close into. We take a lot of effort to say that something caused something. One of those approaches is called linear regression. Vaishali, have you heard of linear regression? You know something what regression can be? What it can achieve? No, regression testing is different.
I know in terms of testing, and I know what linear is.
Okay. So regression testing is a different thing. Okay. This is not that concept. So what does linear regression do? It is usually used to predict what would happen next. A regression model is usually used to predict what will happen next. Okay. And to do that, you have various steps to be followed. So how do you do that? You usually take a sample that we discussed in our first class. Those samples are taken and then you find out various factors which could be impacting your hypothesis. You consider or collect the data about those factors, put them into a model, find an equation out of it, and then see, is it really significant? When I say it is, how much is it significant? To find that out, you use something called as a normal curve and you use something called as a z statistic. Okay. Can you see how things are being slowly related to each other, or how would it be in future? Say suppose, so let's take an example. uh, I want to find out what would be the sales of my new store next month. Okay. So now my y variable, which we called as dependent variable, because it is dependent on various other things, is the revenue of my store, right? Now that equals to a function, as I was explaining in the previous slide. A function is usually a description of a graph or a curve, right? Just like the probability density function of a normal curve that I was explaining here. This x would be a combination of many variables in a linear regression. So it will eat various variables, give out the revenue. And then we can say that these variables caused this. We are establishing a relationship of causation and using this function to predict this. Please let me know if I went too fast or if it is confusing. Let me explain it again.
So in this, the linear regression, this formula should not be y is equal to like mx plus c, something like that.
Yeah, it can be mx plus c also. It can be mx1 plus nz,
Yeah, whatever.
nh2
Yeah.
plus whatever it is.
Okay. It's like same thing, right?
Yeah.
Okay. Got that.
Okay. Formula is to calculate linear regression. Formula is to calculate the dependent variable. This whole formula is linear regression. So basically why is it named linear regression is it's a graph which is straight in nature. The curve is straight line. So it is called linear. Now, why is it called regression? Because it learns through various parameters and various individual elements x1, x2, x3, xk. It regresses upon these in a linear fashion to make this curve. Hence, it is called linear regression. We'll get into a bit of depth into this. Yeah. So, Aarti, you were saying something. Y is equal to mx plus c.
Yes.
This is something like that.
Correct.
So, from this equation, we usually tend to find out something where beta 0, this is the error that we have, this is the constant variable,
Yes.
and then this is the coefficient.
And this is the data. Yeah.
Can you try to read this once and try to understand the relationship between regression and correlation?
Okay. What is the relation between regression and correlation? Correlation is the relationship between two variables, while regression helps us understand the effects of one variable over other. Okay. Correlation explains the relationship together,
Sorry.
while regression explains cause and effect. If X is correlated with Y, then Y is also correlated with X, but in regression, it's only one ways.
Was it clear?
So the third one, if X is correlated with Y, then Y is also correlated with X. So you mean in regression, it should be only just one way if X is related to Y, but Y won't be correlated to X then. That means, right?
No. If there is a correlation between rainfall and temperature, that also means there is a correlation between temperature and rainfall, right?
Yeah, but why it says only one ways means?
But in regression, it is usually like this, that either temperature has caused rainfall or rainfall has caused temperature. But if rainfall has caused temperature, then temperature will not cause rainfall.
Okay, so only one way, that means not like vice versa.
So something will cause it, right?
Yes.
It usually is one way.
Okay, got it.
That is the difference between correlation and causation.
Okay, regression. Okay. Yeah, I got that.
Yeah. So Vaishali is asking for an example of correlation and regression. Let me give you a real life example that we did with regression. Now, what I had to do is I had to predict what would be the sales of a particular customer in the next quarter. Okay. Now, to do that, I need to first establish a causation. What are the things those are causing sales in first place? Okay. Now, those can be his geography, his segments that he's dealing in, the affluence, the marketing that he's doing, all these factors. And then I'll try to find the causation. This is an example of regression analysis. Yeah, exactly. Okay. Now, while doing this regression, as we're trying to establish the causation with different factors. Okay. Now, suppose there are two factors which are how do I say, which are being correlated with the sales in an equal fashion. So say suppose competitor 1, I have the sales data of competitor 1, I have the sales data of competitor 2, and I have the sales of my store. Now what I'll do, what I have to see, do I need to have all the data in my linear regression or not? So for that, what I'll do, I'll try to see how are they correlated with the sales of my store. If both are equally correlated, I need not have those two variables. It would be like double counting.
But in that case, can't we use the multiple regression to find out that?
In a multiple regression itself.
Yeah, because it's like more than one variable we are taking, right?
Right. In a multiple regression, one variable is the sales of my competitor 1, second variable is the sales of competitor 2, and I have sales of my own store. Okay. Now, how will I make sure that I need these two factors are correct for my study or not? Do I need these both factors or one is enough? Now, for that, yeah, please tell.
Yes, I think for that, I think we need to check that covariance, or like the correlation between these. Yeah, correlation. Yeah, correlation between these variables, how important these are, and yeah. That's
And then we'll put it into a linear regression.
Yes.
Okay. Can you find the difference between correlation and a regression now?
Yeah, they are different. Yeah.
Vaishali, did you find, or we need to? I can have one more example round.
Yeah, still I'm not sure about how correlation will matter here. So you said it is correlation. Sorry, regression is affected sales and causation are the different factors which cause the sales.
Right.
And correlation is other competitors.
Not other competitors. So in that regression example that I was giving, where I had to find out the sales of my store, suppose I have 20 factors that I've considered, right? In those 20 factors, 2 factors are sales of competitor 1 and sales of competitor 2. Now I have to use these 20 factors and then see how is it really impacting or I have to establish a causation with the sales of my store, right? Now, while considering those 20 factors, how would I know which factor to be considered, which factor to be not considered?
Okay.
And the factor which is not correlated at all, I'm sure that there won't be causation for that. It won't give me any result, or my hypothesis is broken in the first step itself. If there is a correlation, then I'll go ahead and try to prove the causation.
So we are looking for correlated factors first, and then
Yeah.
relation.
I mean, don't take it as two steps that we do. I'm trying to explain the difference that let me give something else here. I think this is very confusing. Okay, so the example that we were using was of rainfall and temperature, right? Say suppose our study would be like this, that what exactly is causing the rise in temperature, or global warming around the world. Okay. Now for that, let's say we take a correlation with the rainfall or the amount of precipitation that is happening. Now we find that there is a negative correlation. Okay. But can we really establish that rainfall is causing the temperature change? So only the correlation will not help us do that. How do we do that? We will use something called as a regression model. We'll find out the errors and we'll find out the significance using a z-score to say that it is really causing temperature change.
So how we use the z-score in this case?
That I'll tell. I mean,
Okay.
just have the idea now.
Okay.
Just try
Okay.
to
Sure.
digest the fact that there is a difference.
Okay.
And there is something called as regression.
Got it.
Yeah, exactly, Vaishali. So if we do not, exactly, we first look into the correlation, because if there is no relation at all, there is no point of proving anything. We don't have anything to prove at all. We only have to prove if there is a correlation established. That is when we use regression. Regression is one among those lakhs of models available today to prove this. Okay, but regression is a very common and building block, which usually is used to predict a certain new thing. Okay. So what I'll try to do is, I'll not give you material as such. I mean homework or assignment that you have to work out. I have certain papers which are basic research papers, not very long, that I'll upload it today. Please take some 1 hour of your study, of your time, go through it, and be prepared for the next class tomorrow. Yeah, I mean, just read through it. Try to understand, basically. Okay. And so, Vaishali, did you get the assignments? You can see the assignments and the PPT in your link.
Yeah, I can.
Okay. Okay. So I'll go ahead and upload this document. Please go through it. And for this, I think you will have to revise your set 2 and 3 once to understand some of the basic concepts and try to relate those things. And then let's come prepared for tomorrow's class. Because this gap of the whole week, I think things would be getting diluted. And let's catch it up this to make it ready for tomorrow's class. Okay, then I think that's it. I'll just circulate this thing and one more material. You can read through it.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.